Welcome to my video lecture. In this lecture, we are going to discuss about uncompetitive inhibitions. So, in the previous lectures, we have discussed about what is uncompetitive inhibition. So, uncompetitive inhibitor generally binds to the allosteric site. So, allosteric site is other than active site. So, especially mean for the inhibitor to bind or any other modulator to bind. So, there are different type of inhibitor which is occupying the allosteric inhibitor. Uncompetitive is one class of inhibitor. To explain this, I will write the enzymatic reaction. Generally, we used for kinetics to explain the single substrate reaction. So, this is the enzymatic reaction, say K1, these are all rate constants, right. So, what is uncompetitive inhibitor? Since these uncompetitive inhibitor are not structural analog to substrate, so that means the structure, so it need not to occupy the active site for its inhibition. So, it will always bind to the other site. An uncompetitive inhibitor is a class of inhibitor where that inhibitor binds only to the ES complex, only to this, not to the free enzyme. Only when there is an enzyme substrate complex is formed, so the allosteric site, that particular site is become compatible to the inhibitor. In a normal free enzyme, that allosteric site is not compatible, so the inhibitor are unable to bind in the free form. So, if I am trying to explain that in a stoichiometric form, so this is the inhibitor reaction. So, it is only binds to the ES complex and it form EAS complex. So, this complex is become inactive. So, if I am including the rate constant, so I say Ki, let Ki and K minus I. So, this is the reaction that we are talking about. So, whenever if we have encounter with the uncompetitive inhibitor, how the equation is changing. So, how to develop that condition, what is the equation for this condition. So, that is what today's class in this lecture. So, let us start. So, always start, this is an enzymatic reaction. Whereas this one is a inhibitor reaction. So, let me do first the equation for rate of reaction. So, rate of reaction is always is how much product is produced. So, we will start with V is equal to dP by dt. So, the dP by dt is all about this particular equation, this one. So, that means it is K3 into ES. Let us say this is equation number I. Now, we have we need to replace this ES. So, because ES is unmeasurable in the experiment, so we are replacing it with the known quantity. So, how? So, we will do that. So, we will take a enzymatic reaction. Let me erase this. Just I take the enzymatic reaction. So, what is that enzymatic reaction? So, as I say E plus S, I am rewriting that. Yes. So, you calculate dES by dt. So if you refer my previous lecture on equation development, you may understand this easily. So I urge you to refer that. So at steady state, so this become the des by dt is become 0. So this equation is simplified into Km is equal to E into S divided by Es. So just refer my previous lecture on equation. So let me, this equation is 1. Right. Similarly, if I am taking an inhibitor reaction, that is Es plus I ESI. So this is Ki, K minus I. So if I am doing similar kind of experiment to this, that is equation to this, so we are trying to calculate ds ESI, because again this ESI is intermediate. So if I am writing Ki into Es into I minus so at steady state, again this particular thing is become 0. So you are simplifying this. So instead of this, you write capital Ki is equal to Es I ESI. So let equation number 2. So we have two equations. Now the next step is we need to calculate the total enzyme present in the system. The total enzyme that is E naught is equal to, so E naught is either present, whatever the enzyme that you have added in the system, that is what E naught. So if I try to calculate that, I need to check what are the enzymes present at what are the forms it present in the system. So here whatever the enzyme that you have added, either this is present as a free enzyme or it may present in a enzyme substrate complex or it may present in the ESI complex. So let equation number 3. Now you take equation number 2 and replace this ESI. What is that equation number 2? Equation number 2 is nothing but Ki is equal to Es into I from ESI. So from this you calculate ESI and substitute. So if you substitute in this third equation, so the third equation become E naught is equal to E plus Es. So instead of this ESI, we are substituting that equation Es into I by Ki. Now you can take here the Es, here the Es, both is common, that you can take it out. So if you take it out, this equation become E naught is equal to E plus ES. So, I am taking out. So, after you take the ES from this, you will get 1 plus, if you take the ES from that, the remaining thing is I by Ki. So, this is, so now you substitute 1 in the above equation. What is first equation? The first equation is nothing but Km is equal to E S by Es. So, just simplifying this equation, you can get what is E. So, E is equal to Km into Es divided by S. Now, substitute this equation in this. So, then the equation become E naught is equal to Km into Es divided by S. So, the remaining equation. Now, again you have Es common in these two terms. So, you can see Es is here, then here. So, again you take that out. So, that the equation become Km, sorry, if I am taking Es out. So, if you take Es out, this equation become Km divided by S plus 1 plus I by Ki. This is equal to E naught. Just take the LCM here. So, this become, if I am taking LCM, this become Es divided by S, because S common, Km plus 1 plus I by Ki into S. So, you can take, this is equation number 4. So, 4 is E naught. So, now keep this equation, you are substituting this 4 in equation number I. So, that is what the next term. Let me erase this again. Just keeping this equation for our continuation purpose. So, now substitute this 4 in I. So, what is I? I is equal to V is equal to K3 into Es. So, from this you substitute Es in that. So, if I am substituting Es, Es is equal to nothing but K3 into Es is nothing but E naught into S. E naught into S divided by Km plus into S. So, let me erase this. So, now you take this 1 plus I by Ki from this equation out. So, like this. So, K3 into U naught, this is nothing but Vm. So, Vm into S, K3 into U naught is substituted as Vm. So, now I am taking that 1 plus I by Ki out, 1 plus I by Ki I am taking out. So, the remaining thing, so since the Km is not having any 1 plus I by Ki, so that need to be divided here. Plus Yes. So now I am writing this equation, V is equal to Vm divided by 1 plus this particular thing I am just bringing up, 1 plus I by Ki into S divided by again Km divided by 1 plus I by Ki plus S. So you can replace this term. So instead of this, I am substituting Vm star. Similarly, here I am substituting Km star. So again the symbol is, you can use the symbol, different book is using the different symbols. So if I am substituting like that, you will get V is equal to Vm star S divided by Km star plus S, whereas Vm star Vm divided by 1 plus I by Ki, Km star equal to Km divided by 1 plus I by Ka. So you have to note this particular point. So how the Vm and Km when compared to the non-inhibited enzymatic reactions. So the value of Vm and value of Km is all about non-inhibited reaction. So the value of non-inhibited enzymatic reaction. So when compared to the uninhibited reaction, the uncompetitive inhibitor whenever is involved, the Vm value is decreased by 1 plus I by Ki, whereas the Km value is decreased by 1 plus I by Ki. So both, very important point, both Vm and Km is decreased whenever there is a uncompetitive inhibitor. So that is a one phenomena that you need to use in order to identify the uncompetitive inhibitor, because each type of inhibitor differs the Km and Vm value in a different manner. So here uncompetitive inhibitor, this is what this is, right. So let me draw the LB plot for the non-inhibitor and uncompetitive inhibitor so that we can understand. Let me erase this. So let me draw the graph. So imagine this is your I is equal to 0. That means I is equal to 0 means there is no inhibited reactions. Whenever, so this is 1 by V, this is 1 by S. So according to the uncompetitive inhibitor, we know that both Vm is Km is decreased by the factor of 1 plus I by Ka. So if I am drawing a graph for uncompetitive inhibitor, you will get a line like this. So this is, you have I and this is uncompetitive inhibitor. So like this, by looking at this graph, you can identify whether this is uncompetitive inhibitor. So this is all about your uncompetitive inhibitor kinetics, how the equation is varying with respect to this inhibitor. Thank you.